Okay, so for this lecture, we are going to continue chapter 7. And I'm going to be looking at the book for part of this and Visual Studio also. We're going to review just really quickly some things about the shift and rotate instructions. So just a second, I need to put my phone to not disturb so it doesn't ring while I record. So the shift right and the shift left instructions. So SHL and SHR instructions, they're going to shift the bits either to the right or the left. And we're going to be adding zeros to the back. So if we shift 1 to the right, then we add a 0, I call it to the back or to the most significant bit. And the last bit that was shifted out is going to be a control flag. The last bit that gets shifted out is the control flag. So if you shift 2 bits to the right, then the very last bit that got shifted out, the second one, will be the control flag. And that's going to be for most of these. So for SAL and SAR, again, the very last bit that you shift out will be your control flag. And then for SAR, we're going to copy the last bit to the bit space that is open. So if we have 2 bit spaces that are open, then we copy that one twice. The SAL works exactly like the SAL is going to work exactly like the SHL. And then, so I'm going to pull up Word document. I think this will help. Just so you can see something as I'm talking. So SHL and SHR shift bit the very last shift bit is control flag. And then we're going to add zeros to the open bits. Okay, so this is for both of those. So example, if we have 1, 0, 0, 0, and 0, 0, 0, 1, and we shift this to the left, so SHL 1, so we shift to the left by 1, then let's say that we move this into AX, and we put AX here, okay? To make a little more sense. Then we're shifting to the left by 1, so this 1 bit is going to go to the control flag. And then we're going to add 1 to here. So we're going to have this opened up in the back, which is the least significant bit, and we're going to add a 0 there. So our new number is going to be 0, 0, 0, 0, 0, 0, 1, 0. Make this bigger. Okay, so we moved this bit out, and it moved out to the control flag. and then we add a 0 in the back. So this number in hex is this here is an 8. Those 4 bits is an 8. And these 4 bits is just a 1. When you number these 4 bits here, there's a 0, and this here is a 2. X. Now, when you look at this in Visual Studio, when you run this, you're going to see the whole EAX register is what you're looking at. So this 1 bit that got shifted to the left, you're going to see it in that register. So I wanted to show you that. So here's an example. Here we have 1000, which is 8, and then 1000, which is 8 again. So this is 88 hex. And then I'm calling dump register so you can see the registers using the Irvine 32 library. And then we're going to shift to the left 1. So when we shift to the left 1, this gets shifted to the left. So this goes out, this 1 bit. So we have 0, sorry. We have 0, let's see if I can change to a pointer. Okay. So we'll have 0, 0, 0, 1, which is just a 1, and 0, 0, 0, 0 with the 0. So we're going to see 10 hex in EAX, but you're also going to see a 1 in front of that. And that's just that this 1 bit, this 1 that got shifted to the left. So it doesn't disappear. You'll actually see it in the register. So let's run it. So we start with 88 in the EAX register, and then we go to 10 in the EAX register. And this 1 that you see here is just that 1 bit that got shifted over. Now remember, this is going to be 1 in hex also. So if you shift more than 1, you're not going to see 2 1s. It's just depends on what it is. You're going to see it in hex. So let me just show you what I mean by that. So here, let's go ahead and shift 2 to the left. So the 1 and the 0 are going to get shifted to the left. So we're going to end up with, in binary, we're going to end up with this. Copy. And we put 2 zeros on the back, the open spaces. So we're going to have 0, 0, 1, 0, which is in hex, that's a number 2. And then this will be a 0. Right, this here in hex is just 0. And this is our binary number. So I'll put a B here at the end to say it's binary. So we shifted a 1 and a 0 because we did a two left shift. So you're not, so let's run it and see what we see in this register. So we have 88, and we said there's going to be a 20, right? 20 hex. But here we see a 2. So the reason we see a 2 is because it takes that 1 and that 0 that it shifted, and it converts it to hex. So remember that, I'll just write it here so you can see. So you have 1 0, right? That gets shifted out. Well, if you add 2 zeros in front of that, 0, 0, 1, 0 equals to 2 hex. And that's why you're seeing that in the output when you run this program. Okay, it's running a little slow. There we go. And that's why you see the 2 there. So those are those 2 bits that got shifted to the left. Now, I'll tell you that if we shift 2 to the left, the control flag is going to be the very last bit that got shifted out. So that 0 is going to be the control flag. If we shift 1, the control flag should be a 1. Now, as I was running this with Visual Studio 2012, which is what I'm running right now, it is not setting my flags correctly. So if I put a 1 here, my control flag should be this 1 that gets shifted to the left. And it's saying that my control flag is 0. So I looked it up and it did say that there were some problems with the control flag getting set correctly when you did byte-wise shifts. I haven't tried it yet on 2019 or 2017, but I'll do that at school. In the Frisco labs, we have both the 2019 and 2017. And in Plano, we have the 2017 Visual Studio. So I'll check those out and see what they do and send you an email. So for right now, don't worry about the control flags, but you do need to know that the control flag that gets set is the last bit that gets shifted out. So this will be a 1, and if it's a 2 byte, if we shift by 2 here, control flag will be 0 because that's the last one that got shifted out. Okay. All right. So for this chapter, for these 2 sections, 7.1 and 7.2, I'm giving you this assignment. And this assignment does not count for points. This is what we're going to do in the class for lecture. This is what we're going to be doing. Okay, so for an hour and a half, we're going to be running all the examples that are in this section 1. My book, by the way, looks a little bit different than yours. So we're going to run this video that's embedded in my book, by the way. It's in your modules video. It's just embedded in my book. So we're going to start, for example, this example. We're going to run this example. We're going to run this example. And all these examples to make sure that everybody is clear how these instructions work. Okay. So these examples in the boxes. Then when you go to section 7.2, they actually show you some practical applications using shift. So shifting multiple double words. And here's the code. So you would run this code and make sure that you understand how is shifting that using SHR and RCR. So shift right and rotate, carry right. Then look at this example and then see how we're multiplying by shifting bits. So make sure you understand how this is working and this code, because you'll be responsible for knowing how this code works. And then here we're looking at a program that's converting a binary integer. So we're looking at binary integer to ASCII binary string. And this is done, we do this a lot when we, just in high level languages, if we have an integer and we want to look at that integer and binary, then this is the code to do that. So it'd be binary to ASCII. And typically we're looking at an integer, like if we say integer 64, and that's in decimal, not binary, but in decimal, we typically look at it in high level languages as an integer 64 and say, okay, what is that? Let's convert that to a letter. What letter is that? That's a capital A in ASCII. So here they're doing it binary to ASCII. So run that one, then extracting file date fields. So if space is an issue, and then a system level software would often save a date like in this format using a binary number. So in this example, we would extract the sequence of bits called bit strings. And this is a date stamp that shows the date on which the file was last modified, this right here. Bits 0 through 4 represent the day number. So here's 0, 1, 2, 3, 4. So this is the day. And then this is the month. And then this is the year. So you would convert this. So this would be 2 or 8. So it'd be date 10. This shows date 10. And then here for the month, we have 1 plus 2 is 3. So January, February, March. So this would be month March. This is 3. And then for the year, we have 1 plus 2 is 3. And this is 32. Let's see, so for the year, it says it's 1999 is the date for the year. So we'll convert that to 1999. Let's see, to extract a single bit string, shift its bits into the lowest part of the register and clear the irrelevant bit positions. So this is the code to actually do that. So they make a copy of DL, the clear bits 5 through 7. But this is doing the AND. Remember when we do an and we AND with the ones, it clears those bits out. And then they save AL into day. Whatever's left is the day. So go ahead and run that code. And here's to extract the month. And then here's to extract the year. Oh, I see. So they took 1980 and they added year to it. So that's why this over here, this is 1 plus 2, just 4, 8, 16. Yeah, this is 19. So this is the number 19 right here. So what they did is they added 19 to 1980, and that gets you to 1999. Okay, so run each one of these and make sure that you're able to understand these. And then hopefully your carry flag is working properly on your system. If not, don't worry about it. Just make sure that you understand how the carry flag is set. So in this document, I actually have 2 examples. And of course, you can just do the examples in the book, but the reason I have these 2 examples on here is I just want to make sure that you know that when you see the register EAX, you are going to see that shift, and that you have the right code. I want you to have the whole code here, because some of you are having problems when you run your programs. You're getting errors. So if you type this in exactly like it is, don't copy and paste it, because if you copy and paste it from Word, it copies some special codes in Word, and then your program's not going to run. So type this in, make sure you have the library, that you have .code, main procedure, exit, main end procedure, and end main. Okay, and then it should run. So some people are leaving out some important parts or adding some things that you don't need, and then it's giving you some error messages. Okay, good luck with this exercise.